answers were in the back that you were checking as you were looking at these. And as you take a look at question number, so was there a question on 5 or is 5 okay? 5 is okay. So you should have looked in the back, you should have had one line that was a solid line, and then you should have had one that went above that was kind of that dashed line, or kind of vice versa it might have been. I think the dashed line was below, wasn't it? No. For Mr. Otterson's, his was cheaper. And then when you look at number 6, so I had some people in number 6 make a table. So they said the jerseys with their no names on them, right? And it doesn't say make a table, it says write 2 equations. And when we write our equations, it is always y equals, because if you didn't have this, please write this down, independent variable, or our dependent variable, so it's the dependent variable, is equal to, so this is from last week, the dependent variable equals our rate of change, which in this case is going to be our unit rate, is going to go here. We're going to use the letter M. This is our unit rate. So in number 7, and then we're going to have it times X, which is going to be our independent variable. So the 2 things that are always going to be the same in my equation is going to be my dependent and my independent. And what's going to be changing for each of mine is that unit rate. So for no names, when we were looking at buying that shirt, and we're looking at the shirts where we have their names on the back, to write an equation, how much are they charging? Dependent variable, that's our cost, is going to be equal to how much per jersey? No names? 7. X. Someone said, well, what about the 150 up here? That's used in the second question in number 7. If they have their names on the back, what was the charge? Y equals 9x. And what you're going to do now for question number 7 is it says determine, use 19 kids on the team. So that means x, that's our independent variable. X is equal to 19. So which equation should I be using? The one with the no name or the name? The name. So y equals 9 times 19 people. So it's $9 per jersey times the 19, which means my cost was, so multiplying that, what'd you get? Take your calculators. Most of you have them sit on your desk, punch it in. 171. So the question is, can you buy the jerseys for those kids? No. Why not? We only have $150. Okay. So that's where that 150 comes in. Okay. Some people were trying to put the 150 equal to 7x and 150 equal to 9x. You don't want it. So if you didn't have that, this is how we're always going to write those equations. Okay. Any other questions on the homework? Okay. So making sure that you had the graphs when you did number 5 and your tables. And please turn in your notes then to E2. Now today in our notes, if we are looking at this, we're going to be looking at 2 different things. We're going to be looking at proportional relationships and getting just a rate. And a rate is different than a unit rate. So a rate could be something like 3 cookies for $1, 6 cookies for $2. It could be so many dollars per pound. It could be $5 for 3 pounds of something that we're buying. That's a rate, not necessarily a unit rate. So we are going to be looking at proportional relationships on a coordinate plane. Our proportional relationships will always go through, anytime we're looking at proportional relationships, always go through 0, 0 on our graphs. Please make sure you add that. When it's a proportional relationship, ours will always go through that point 0, 0. So when we're trying to determine if something is proportional, at the top, if you didn't add that, go through the point 0, 0, make sure you do that. We're going to look at graphs, tables, and equations again. Okay? So as we are looking at those graphs, tables, and equations, so right up here you're writing that. Okay? So when we look at our vocabulary, Zach, would you please read?
Proportional relationship is a relationship between things that change together. In other words, they always have the same equal ratios.
So, keep going.
For example, if one item is double, the other item is also double.
So in this case, it tells us we have 3 cookies for $1, which means we'd have 6 cookies for $2. And your first homework question is very much like this. And it says, okay, well, how much for 12 cookies? Well, if we think of starting with 3 cookies, how do you get from 3 to 12? You take it times 4, and that gives us 12 cookies, right? So if I'm looking at it, it was 3 cookies for $1, which means I'm now going to take the $1 times 4, and it should be $4 for 12 cookies, right? So when I start your homework, I had some people thinking you needed to find a unit rate. You are not. So you're writing this down, what I just put up here. So it says, how much will our 12 cookies cost? We should have 12 cookies for $4. It's proportional when we look at that, right? So our answer is going to be $4 because we took 3 times 4 and then the 1 times 4, okay? If I would have said, well, how much for 24 cookies, right? We wanted to find 24 cookies. We'd go back to that it was 3 cookies for $1. What do I have to take times 3 to get 24? 8. So that would be for $8, right, if we were looking at that. So it's proportional. I know that the ratio is going to stay the same. When we start talking about slope, slope is a ratio. I think students often get confused and think that it has to be something with the x. It is not. It's simply a ratio, like a fraction. So we are going to watch this video and you are going to be filling in. So when you watch it, it's about 4 minutes long. You're going to be putting in the pounds and the costs that they give you in this situation, and then you're going to graph them. So you'll graph each one. So if they tell you what the numbers are, you're just going to graph and put those in.
How can you show an infinite number of possible answers? Suppose egg salad costs $5 per pound. Here are 3 possibilities for numbers of pounds and how much they would cost. But you can't list all of the possibilities, so how could you show all of them? In this lesson, you will learn to display all of the possibilities in a proportional relationship by graphing. Let's review what a proportional relationship is. Here's an example, 30 miles every 2 hours. Here's another example, 2 pounds cost $6. The key thing is that you have one type of unit matched with another type of unit, pounds to dollars, for example. And the other key thing is that you can get other examples of pairs within that relationship by multiplying or dividing. For example, if 2 pounds cost $6, you could double or multiply by 2. To get that 4 pounds cost $12. You can do that because it's a proportional relationship. You could also, for example, triple the original and get that 6 pounds cost $18. In this lesson, we'll be making graphs. It's very important that you use equal steps when you make the scales. For example, suppose you wanted to plot these 3 points. It's tempting to want to just use 2, 5, 11 as the labels for the tick marks on the y-axis, but you can't do this because that's not equal differences between those numbers. 0 to 2 is not the same as 2 to 5, and that's not the same as from 5 to 11. So as tempting as it would be to do it that way, that doesn't work. What you need to do is to count by equal steps. For example, count by 4s, 4, 8, 12. Counting by 4s gets us past 11, which is the largest y-coordinate we need to plot. Okay, so how do we graph a proportional relationship, like 2 pounds for $6? You might start by making a table, weight and cost. There's 2 and 6, and I'll just use as 2 more examples the doubling and tripling that I talked about earlier. We keep this table. We set up a coordinate plane. Notice that I've scaled my axes correctly.
So going up by
Weight,
ones
or the
and by
individual
one.
variable on the x-axis, cost on the y-axis, and I plot these 3 points. Now here's the key thing. These are not the only 3 pairs within this proportional relationship. any ordered pair on the line through the origin that these 3 points lie on will be an ordered pair in this proportional relationship. So for example, if I take my 2 pounds and my $6 and I decide to divide by 2 so that I get 1 pound for $3, hey, take a look. That ordered pair is also on the line because every ordered pair within the relationship is on the line. The reverse is true also. Every ordered pair on the line is an ordered pair in the relationship. So for example, this point, 3, 9 is on the line, and indeed, if I triple the picture that you see on the screen right now, I get that 3 pounds cost $9. Every single ordered pair on the line, even one halfway between, like this one, satisfies this proportional relationship. And the arrow means that it keeps going. So this is a way to diagrammatically depict all of the ordered pairs in the relationship. We can do the reverse. Suppose you're given a graph. How can you name in words the proportional relationship that's described here? Well, you just need to pick an ordered pair like this one. It looks like 2 hours, 30 miles. So you might say 30 miles in 2 hours. But any ordered pair would do just as well. Someone else might pick this ordered pair and say...
Okay. So you should have first the 30 miles in 2 hours written down. Write that one first. 30 miles in 2 hours, or 3 hours. 30 in 2 hours, and then the 45 in 3. Make sure you have both those down.
45 miles in 3 hours. Each of those is a description of the same proportional relationship, even though the numbers are different. So either of those, as well as many other possibilities, would be correct. In this lesson, you will learn to display all the possibilities in a proportional relationship by graphing.
So when we are looking at that, what we now want to look at is, you should have had this totally filled in. So if you were telling me your numbers that we should have filled in on this one, you had your 2, 4, and 6, right, back on that page. So I should have 2, 4, and 6. I should have had the cost, which was our... As we were looking at, that was our 6, 12, and 18. And I should see your graphs. So I should see at 2, you were at that point 6. At 4, I should have seen 12. And at 6, I should see 18. And then you are always going to take and make a straight line. So if you want to use the edge of your workbook at this point to see a proportional relationship, what we are always looking for is that one of the homework questions asks you this, is how do you know if it's proportional? It's going to be a straight line, and it will go through this point 0, 0. Straight line through 0, 0. So we did this one where you put, what did you guys write first, the 30 or the 50 or the 45? So it doesn't matter if you had 30 miles, right, in 2 hours. That's what we were looking at in 2 hours, was this point here. Or if you had 45 miles in 3 hours. And what if I said at 1 hour, what would you have told me? And at 1 hour, so we have 15 miles in 1 hour. So make sure you do that one also. This last one is our unit rate. The other ones are just rates. So when you do your homework tonight, I would be okay with 30 miles in 2 hours or 45 in 3. And if it asks on the second half of your assignment for unit rate, then you want to simplify that or find out at 1 per 1. Okay? So this next video, as you are looking at this part, they are going to be telling you about how to find your unit rate. So right now, what I want to do is fill in before we do this so that as you're watching the video, they're going to tell you 3 ways. And they're going to take you through each of these graphs. And I want to fill this part in with you right now. So please write on the top of that next page, so it's on the top of page 7, where it says, what are the 3 ways to find unit rates? Tonight when you do your homework and you're asked to find unit rate, these are the 3 ways that I want you to do it. So the first one, I want you to say that we are going to do this. So we are going to find 1 On the independent variable, which is which variable? Which one is our independent? Independent. Independent is our x. So 1 on the independent variable, or when we look at the table, when we see the x value equals 1, it is the y value. So then we're going to find what the independent is x, or in the table x equals 1. We're going to find the y value. The y value will be our unit rate. So there'll be a number. Like on this one up above, what would you say the unit rate is at 1? It looks like it's at 3. If we go to this right here, we go up from the 1 here, right? We can also see 3. So at 1 on the graph, at 1 in the table, both ways, we would say that this one is going to be $3 per 1 pound. That is a unit rate. The second way that you're going to find your unit rate, we're going to show this in the video as you go through these next couple of places in your notes. You are going to pick an ordered pair. So pick an ordered pair. Please write this as you are, so that then as you're watching the video, you can kind of just hear him explaining this. We're going to pick an ordered pair. Ordered pairs are always x, comma, y. That first number always told us to go left or right. The second number told us to go up or down. You're going to pick the ordered pair, and then you're going to take the y value, and you're going to divide it by the x value. So it might be written that way. Sometimes people like to do it this way. This will always equal your unit rate. When you take y divided by x, this will equal your unit rate if you would go through the point 0, 0. If it doesn't go through 0, 0, it's not necessarily a unit rate. But most of ours that we start out are all going to go through that 0, 0. The third thing that you are going to do, the third way, is on some of your graphs, they're not going to have a scale, okay? So you're still going to look at the ordered pair. You're going to look at one ordered pair. When we look at the one ordered pair, we're going to think of that as xy. We're going to take that xy and we're going to determine what is one more for our x. So you're going to see it in your graph when they do this one. Determine one more for our x value. Remember, that's our independent, moving one more to the right. And what you're going to do when you find that is you're going to determine how far up you move. So how does the y move? And you'll see this in a minute as we watch this video. How that y moves is going to be what's called our change in y per 1 x, which is our unit rate. That is our unit rate when we look at that. This symbol for that triangle, that doesn't mean triangle y. That symbol means change. Okay, so anytime you see a triangle like that, it means the change in y. And how would you find the change in y? What does change usually mean? Are we adding, subtracting, multiplying, dividing? What do you think of for changing? So if I'm going to find the change from here to here, what am I going to do with these two values? I'm going to probably subtract them is what we're doing. So usually change is going to be subtraction, okay? Usually subtraction, okay? So I'm going to put this video on. And as you are looking at this video, they're going to start here. You're going to answer these questions, okay? You're going to circle which graph, if it's dollars per pound or pounds per dollar. We're going to put that definition of our unit rate. I'll come back to that in a few minutes after you've watched the video.
How do you find how fast something is going from a graph showing the time that has passed and how far it has gone? In this lesson, you will learn to find a unit rate by using a graph. You've already learned that if you have a proportional relationship like $6 for 2 pounds, you can make a table of values and graph the relationship. You've also already learned what a unit rate is. A unit rate answers how many dollars for 1 pound in this case, or in general, how many of the dependent variable for one of the independent variable. In this example, we would find the unit rate by dividing 6 and 2 by 2 to get $3 for 1 pound, or $3 per pound. A common mistake is to reverse the variables when giving the unit rate. So for example, if you're looking at this graph, the unit rate is going to be the number of dollars for 1 pound, not the number of pounds for $1. Suppose you have a table and a graph.
Did you guys get that definition? Unit rate. It is the number of the dependent variable per one independent variable. So in your notes, that was that definition that they're looking for. Okay? That is not hashtag, it's the number of the dependent variable. So that's over here, our cost divided by 1 on the per one independent variable. So we can always look at per 1 as we look at that. Okay?
Dollars for 1 pound, not the number of pounds for $1. Suppose you have a table and a graph of a proportional relationship. Let me show you 3 very important ways to find the unit rate, all 3 of which are important.
These are the 3 ways that we just put down.
Since a unit rate means the number of dollars for 1 pound, or the number of y's for 1x, you can just find 1 in the independent variable column, or on the graph, and then see what corresponds to it. From either the table or the graph, you can see that the corresponding number is 3, so the unit rate is $3 per pound. Another possibility is to pick any ordered pair, such as 4 pounds cost $12, and divide. 12 divided by 4, again, gives you $3 per pound. Again, from the graph, you could pick the ordered pair, find the 2 numbers that the ordered pair represents, 12 and 4 in this case, and divide, and you get $3 per pound. A third way to find the unit rate is to look at any ordered pair, such as 4, 12, and then say, okay, suppose at the last minute I decided I wanted to buy 1 additional pound. How many additional dollars would that 1 pound cost? From 12 to 15 is 3 additional dollars, so it's $3 for that 1 pound. Or on the graph, suppose you were planning to buy 4 pounds, that would cost $12. If you decide to go with 1 additional pound, that would take you up from $12 to $15. That difference of $3 for that 1 pound is the unit rate. What's the unit rate for this proportional relationship? Well, in this case, the fastest way is just to find 1 on the x-axis and see that 1 hour corresponds to 2 kilometers.
So this is as you're filling in
So the answer would be 2 kilometers per hour. What's the unit rate for this proportional relationship? Notice that this time there are breaks in the scales, which means we can't just look up 1 on the x-axis because it's not visible. Well, we can use one of the other methods. Pick any ordered pair on the graph, find its coordinates, and divide. 30 miles in 10 hours, 30 divided by 10 is 3 miles per hour.
3 miles per hour.
One more example. What's the unit rate here? This time, not only do we have breaks in the graph, so we can't look up 1 on the x-axis, we also don't have labels for the scales at all, although I will tell you that 1 tick mark equals 1 unit. Here we need to use the third method I showed. Pick any ordered pair on the graph, and imagine that you knew its X
And
and Y
imagine that
coordinates.
you knew its X and Y
To
coordinates.
find the unit rate,
To find
imagine
the
that you
unit
decided
rate,
that you
imagine
wanted
that you decided
1 more
that you
pound
wanted
than you had planned.
1 more pound than you had planned.
Find the corresponding tick mark
Find
on
the
the
corresponding
y-axis,
tick mark on the y-axis.
and you can see
So
that
moving
that
one
one
unit
additional
over.
pound
that one
resulted in a
additional
cost
pound
of $4
resulted in
additional
a cost
dollars.
of
So
$4
even without
additional
seeing
dollars.
any
So
specific
even
numbers
without
on the
seeing
axis,
any
we know that
specific
the
numbers
unit
on the
rate
axis, we
is
know that the unit rate
$4 per pound.
is $4 per pound.
So when we are looking at these, you should have had, as I was looking at your notes, if I go back to problem, as I'm looking at problem 3, I should have seen that our unit rate in that one was $3 per pound, and you should have had the definition that they gave us. That the number of dependent variable per one independent variable. You should have circled which one. Which one were we looking at? Dollars per pound or pounds per dollar?
Dollars, because if we look at that, that's on our y, so it should be y over x, and our y is dollars, and our x is pounds. So we should have circled this first one, okay? We looked at this one. They kind of showed you how to fill that in. We put that in our notes already. For our unit rate on the top of, for problem 5, you should have had your unit rate. And again, they were looking at going, in this case, by taking that point and just dividing 2 kilometers per hour. You could have done that looking at the graph here for the unit rate, right? So you could have used this point. You could have taken this point and said, oh, this is located at 2,4. And I'm going to take 4 and divide it by 2. And I always have my units with it, so kilometers per hour. That would be a rate. This is my unit rate, so when you divide that, okay? This next page is where, again, they talk about, oh, we can just find a point. Because of it being a broken graph, could you tell at 9 where the point is? 9 and what? 27. I mean, they don't have 27 written in, but it looks like it's going up, right? By ones here. So you could have taken 27 divided by 9. You could have taken 30 and divided it by 10 because our ordered pair was 10, 30. And you are always taking the y and dividing it by the x to get that unit rate. So when you do your homework tonight and you get stuck, starting on question 7, the unit rates, this is what you're finding. So the 3 miles an hour. And then that last one, this is the one where they say, okay, you know what? We have no idea what the numbers are down here in pounds, and we don't have any idea what the cost, what our scale is. So as I move 1 unit over, I am going up 1, 2, 3, 4 units. So my answer is going to be for my unit rate is that we are looking at $4 per pound. So if they don't give you a scale, and you will see ones just like each of these examples as you do your homework tonight, okay? So I would like you to turn to your homework because I need to give you a few hints. Some of these are kind of hard to read, and as you are looking at your homework, I want to give you a few hints that are in there. So the first ones, as you start off, do you remember last year putting ratios as you were looking at? So when you're doing ratios last year in 7th grade, that's a huge part of 7th grade math, is doing ratios. So when we look at question number 1, we could write that as a ratio. It was 3 pounds of egg salad for $2. So if we are looking at that, do we want to go pounds per dollar or dollar per pound? We want to go dollar per pound. So we're going to put $2 per 3 pounds. So on our scale over here, this is going to be our unit for our pounds, right? Our label up at top would be egg salad. So you want to tell me what you're talking about in each of your graphs. And we're going to have our dollars going up over here. To me, it makes sense if I'm looking at this graph to possibly just go up by ones, same with my pounds, okay? So we're going to have, if you are going
in pounds, I'm gonna have 1 pound, right? And I have 2, okay? So put your numbers going across, okay? And then going up, and someone said, do I have to write every single number here? No, you could probably just write the 2. You could write 4, you could write 6, okay? 8, 10, and we probably want to go to 12 because they do ask us for 12 pounds, and then they talk about the $6, okay? So our dollars going up, I might go, depending if you want to set your scale, we could have $1, so this would be our $2, right? We're going to have $4, and have $6. Can you plot that first point that they gave us? $2 for 3 pounds, right? So if you're looking at your graph, you're going to go to the $2, and we're looking at 3 pounds, right? Would you say if we have 0 pounds, it costs $0, right? So 0, 0, okay? And they say, okay, well, how much for 12 pounds? Do you remember last year doing something like this? So if it's 3, what do you take times 3 to get 12? 4. So you're going to take your numerator times 4, 2 to get your answer, right? So my hint is when you do part B, set it up the same way. You're going to go $2, and it's still for 3 pounds. And you are asked, when will you get $6? So you're trying to find out how many pounds down here, right? This one, you're trying to find out how many dollars, okay? When you take a look at question number 2, it says there's many correct answers because you're asking for a rate, not a unit rate, right? So it doesn't have to be per one. You could pick any number along here. So if someone wanted to pick this point and someone else wanted to pick this point and someone else picked this point, all of those answers would give you the right answer. You just have to label your answer as you look at that, okay? Please take a look at number 3. Number 3 is asking you which one of these is not a proportional relationship, and then you have to explain why. As you look at number, on the top of the next page, number 4. As I'm looking at number 4, my hint would be that you might want to have your scale, because it says 15 miles in 3 hours, so you're going to have your hours, and you're going to have your miles. And I would probably go up by 5s for my miles. 5, 10, so this is going to be 15. And for my hours, I would probably just go with 1s. Okay? So they ask you, using that 15 miles in 3 hours, you're going to set it up almost exactly like we did number 1. It's a ratio. So Dallas, if I'm writing my ratio of 3 miles or 15 miles in 3 hours, what am I going to put in my numerator? 15 miles in 3 hours. I'd write it as what? 15, and I'm going to put my unit miles with that. I'm going to put 3 hours. And the question said, well, how much for 12 hours, right? So we know the 12, and you're trying to find this answer. You're going to graph all of these, okay? So you're going to graph 15 miles in 3 hours, so you go to 3, and you're going to put a point at 15, right? After you find this one for 12 hours, you're going to put a point. And then this one for 75, you're going to look at that point. But again, set it up, 15 miles per 3 hours, and put it equal. This next one, this one throws people a lot. So let's look at number 5. And you read what it says.
Graph a relationship that is not proportional. Discuss why it is not.
So key thing for it to be proportional is what's one thing? There's 2 things that make our graphs proportional. What's one of them? Go on.
They're both
Okay, let's not look at this. Just going back to our definitions, what we talked about in class. What do we know makes it proportional? 2 things. One of them is what? Turn back in your notes if you need to. It has to go through 0, 0. That's one of the things. What's the other thing? Anybody? For it to be proportional. All the ones in your notes were proportional. What was key about all of these things? They went through 0, 0 and what?
What do you see? What is this? A straight line. Proportional is a straight line and it has to go through 0, 0. So when you do that question, the reason it says it already tells you it's not proportional, right? We know that. If you know the side is 1, what's the area of the square? Okay, so remember, this is your side. How do you find the area? If the side is x, right? How do you find the area? You take 1 times 1, which gives us 1. What's the area of each side is 2. So you have to fill that in. This goes back to our first unit of the year. Okay? This next one, I think it is really hard to see the points, so I'm going to give you this one at 5. Put this ordered pair 5, 2. And the other one that I think is really hard to see is at 10, 4. So please put those 2 ordered pairs, because without those 2, I think it's really hard to come up with your answer. There are many correct answers, as it says, for that. And then this is where you start doing unit rate. So as you look at that next page, you're doing unit rate on page 5 and then on page 6. So you should have everything through page 6 done when you come in tomorrow. You have the rest of the time to work. You should be able to go pretty fast. This is not hard stuff. Some of you are probably almost done with most of these on this first page. Okay?